second chapter, right? Okay, so what do we want to study? Good morning. We are learning our subject, that is data mining 3160714. In that, we want to study the module 2, that is data pre-processing, right? We want to pre-process the data. That is, before applying any data mining algorithm, we have to pre-process. Now, what sort of things we are doing in pre-processing? That's what we are interested in knowing, right? So syllabus is having, say, data summarization, cleaning, integration, transformation, reduction, discretization, concept hierarchy, feature extraction, transformation, selection, dimensionality reduction, and CUR decomposition. But, 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 we will study few required basic things, and then after we'll start with the particular topics which are there in the syllabus, right? So let's see that. Data mining to data sets. What do we mean by that? Data mining is to be applied on data sets. See, people who have already studied the Python for data science subject, they know that they are having the data set. On that, they are applying the algorithms, right? And that's what we want to do here. That is, data mining is to be applied on the data sets. Prerequisite for data pre-processing is types of data and data sets. So let us know the types of data sets and data. Okay, so first of all, data sets. So they can be of type, record, graph and network, ordered, spatial, image, or multimedia, right? So for record, what do we say? Relational records, data matrix, numerical matrix, cross tabs. Document data, they can be text documents, term frequency vector. That is what we are talking of TF-IDF, right? So we can say that when text documents are there, we are considering the term frequency vector. Transaction data can be there. So if we consider the data sets of record type, we can consider all these things. If it is of graph and network, we can say how it will be: World Wide Web, social or information networks. See, for social and information networks, we can say that the network structure is there, right? Graphs are being used to find the distance between the people. That is, if one person is friend of mine, that person is having other friend, then me and that third person is also related, right? So we can say that the information networks, social networks, they are using the graph and network type of data set. Ordered data sets, that means what? Video data, that means sequence of images. Temporal data, that means time series. Sequential data, that means transaction sequences. Genetic sequence of data, right? So next is spatial. People say it is spatial also. Image and multimedia. In that, what do we consider? That is spatial data, that is maps, image data, video data, right? So this type of data sets can be there, on which we have to apply the data mining algorithms. Fine. Important characteristic of structured data. We know that we are having the data warehouse wherein we are having structured data as well as unstructured data, right? Let us consider the important characteristics of the structured data. So that is dimensionality. Curse of dimensionality, sparsity, only present counts. Resolution, that is, patterns depend on the scale. Distribution, that is, centrality and dispersion. So, what is curse of dimensionality? Let us see that. The curse of dimensionality refers to various phenomena that arise when analyzing and organizing data in high dimensional spaces that do not occur in low dimensional settings, such as the three-dimensional physical space of everyday experience. So, what do we mean to say is curse of dimensionality refers what? It is various phenomena that arise when analyzing and organizing data in high dimensional spaces. We are not considering only 2D or 3D. We must be having the high dimensional spaces, right? Sparsity, percentage of cells in a database table that are not populated. That means how space is empty, right? Sparsity is how space is empty, how much it is empty, right? So that is what is sparsity. Data objects, data sets are made up of data objects. That means a data object represents an entity. For example, sales database. That means where we can consider customers, store items, sales. For medical databases, we can consider patients and treatments. Many other can be there. We are only looking at the example. Fine. Say we are having university database, there we have to consider student, professors and courses. Also called samples, examples, instances, data points, objects, tuples. Right? So data objects are described by attributes. Database rows, they contain data objects, and columns contains the attributes. Fine. So what are attributes? Attribute or dimensions or features or variables, they are fields, data fields representing a characteristic or feature of a data object. As for example, customer ID, name, address. Fine. Now, the types of data objects, or you can say not data object, but at least we can say part of it, that is attribute. For that, they are of types nominal, binary, numeric, that is quantitative, interval scaled, and ratio scaled. So, what are they? The attribute types. See, why do we require? You can say that for say C language or any particular language, we first of all see what are the basic data types available, isn't it? So here also we try to understand what are the types of attributes available, and based on that we can apply a particular algorithm. Fine. So let us see the attribute types. What is nominal? They are categories, states, or names of things. The values of a nominal attribute are just different names. Like say hair color, black, blonde, brown, gray, red, white. marital status, occupation, ID numbers, zip codes. They are having the categories, states, or names of the things. And that is what is nominal type of data. For data mining algorithms, it is needed that this data is nominal, then you can apply this algorithm. If it is of other type, we can apply other algorithm, right? And for that only, I am showing you all these things, right? Otherwise, in syllabus, you can say, ma'am, these things are not there, but these are the basics. Fine, okay. So let us say next one is the binary. We can understand that nominal attribute with only two states, 0 and 1. That is binary. That is, binary is specific type of nominal where only two states are there. So there are two types of binary attribute. One is symmetric binary. That means both outcomes equally important. Like we can say gender. Though there is inequality in female and male in the society, what here we say that both outcomes are equally important. Whether we are getting female or male, both are equally important, right? Second one is the asymmetric binary. So what? Outcomes not equally important. Medical test that can be positive versus negative. Convention assign one to most important outcome. As for example, nowadays we can say corona positive, right? Or we can say other example is HIV positive. Fine. So when positive is there, it is more important. More important in the way that we can give the treatment, or you can say we can apply some algorithms that is for detection, other things, detection of other things, like say person is corona positive, then other things, other characteristics are being checked, and you can say that the data mining algorithms, some functionality like clustering, classification, or any other types of things are being applied on that, right? So what we say is one that is positive is important, negative is not so important, or you can say we can ignore that, right? Okay. So symmetric binary where both outcomes equally important. Female and male both are important, right? It's equally important, not like important. They are equally important. But asymmetric binary, we can say that outcomes not equally important, right? The next type is ordinal. The name itself says that values have a meaningful order, but magnitude between successive values is not known. What does that mean? You can say 1, 2, 3. So order is there. So can we have that? Yeah, you can have. But magnitude between successive values. Say if we are having 1, 2, 3, we can say that the difference, magnitude between those values is 1. 1 plus 1 is 2. 2 plus 1 is 3, right? So that is the magnitude between successive values is known. But here what is being said that we should not know that. That means we'll consider, say, size is equal to small, medium, large. For you can say army rankings or any other thing, right? Grades, right? So here we already know that the small is the smallest, or you can say its ranking is, say, if we are considering in case of 1 is smaller and 3 is more, then you can say for small ranking is 1, for medium ranking is 2, for large ranking is 3, right? But do we know the magnitude difference between them? Can I say that small is 1, medium is 2, large is 3? Can we say that the magnitude, that is a value difference? No, we cannot say. Fine. So that is ordinal, where the orders, meaningful order is there, but the value difference is not known, right? Now we want to have the numeric attribute types. Quantify, interval or real valued. Interval, what is that? Measured on a scale of equal sized units. Equal sized units, right? Values have order. As for example, we can say temperature in Celsius or Fahrenheit. Calendar dates, equal size units, right? No true 0 point. We are not considering the 0 point. Is it so? See, we say that there is no 0 point, that this is the origin and then after it is starting. So no true 0 point, right? 0 point can be there, but no true 0 point, right? Okay. So ratio, that is the second type of numeric attribute. There we can say that inherent 0 point is there. We can speak of values as being an order of magnitude larger than the unit of measurement. What does that mean? For example, 10 K degree in Kelvin, right? 10K is twice as high as 5 Kelvin, right? That is temperature in Kelvin, lengths, counts, monetary quantities. You are 100 times richer than any other, right? Okay. So what do we say is you are 100 times richer with $100 than with $1, right? Values are given, but the ratio is there, right? These many times. That means we are taking the ratio and we are able to say that it is this many times, right? So we are having the interval value. That means equal size units are there. And in ratio, we can say that it is sometimes more than this one, right? Next is discrete versus continuous attributes. So what are they? Discrete attribute has what? Has only a finite or countably infinite set of values. Countably infinite. We are not considering 1, 2, 3, 4, 5 up to infinite, but countably means you can say to some limit is there, right? Countably infinite, okay? So discrete attribute has only a finite or countably infinite set of values. As for example, zip codes, profession, set of words in collection of documents, sometimes represented as integer variables. Note, binary attributes are a special case of discrete attributes. Okay. Next is continuous attributes. What does that mean? It has real numbers as attribute values. As for examples, temperature, height, weight, cost of house, something like that, right? Price of house. Practically, real values can only be measured and represented using a finite number of digits. Continuous values are typically represented as floating point variables. Now see, here we have seen these two types of attribute. One is discrete, second is continuous, right? In the difference between classification and prediction, we have seen that prediction works with the continuous valued functions, right? So there, this continuous word is useful. Fine. The data mining algorithms are designed in the way that they can typically work with discrete attributes, but only specific cases are there which will work with continuous attribute. Otherwise, we need to convert continuous attribute into discrete attribute, and then after we can apply any particular algorithm. So it is the basic statistical descriptions of the data. For that, we can say motivation. To better understand the data, central tendency, whether the data is available around the mean of it, its variation, its spread, right? So, next is data dispersion characteristics. What does that mean? That can be found using median, max, mean, quantiles, outliers, variance, etc. Numerical dimensions that correspond to sorted intervals. In that, what do we consider? That is data dispersion, analyzed with multiple granularities of precision, right? Multiple granularities of precision. Box plot or quantile analysis on sorted intervals, right? Dispersion analysis on computed measures. What it is having? That is folding measures into numerical dimensions. Box plot or quantile analysis on the transform cube. Now, how to measure the central tendency? That is using mean, median, and mode. Many a times, such numerical examples are being asked in the GTU paper, that the data, some numbers are given and it is told to you to find mean, median, and mode. So, how to find the mean? For that, we can say it is sigma xi upon n, right? X bar is equal to sigma xi upon n, or otherwise we can say mu is equal to sigma x upon n. Fine. If it is weighted arithmetic mean, that means we'll consider x bar is equal to sigma wi xi upon sigma wi, right? We can be having the trimmed mean. That means what? chopping extreme values. See, chopping extreme values, that means if we are having say 5 data. So let us say that I remove one data from right side, same way I remove the data from left side. So you can say now we are having 3 data, and from that we are calculating the mean. So that is what is called as trimmed mean. Fine. Second is median. That is middle value if odd number of values are available, or otherwise the middle of two values. Okay, it can be estimated by the interpolation. The third term is mode. What is that? Value that occurs most frequently in the data. So we can have unimodal, bimodal, trimodal, right? How to find that? For that we can say mean minus mode, that is equal to 3 multiplied by mean minus median. So let us see the example of mean, mode, and median, as typically these examples are being asked in the paper. And for applying data mining algorithms, we need to have these things. Fine. Okay. So let us see mean. That means we know that sigma x upon n, right? So say example is there. We can say few data are given here. Say 15, 13, 18, 16, 14, 17, 12. Now if we want to find the mean, we know that x bar is equal to sigma x upon n. So what we have to do is, we have to take all this data, take the summation of it, and number of data, that is equal to 7, right? So what we get is the summation of these numbers is 105, and total number of data is 7. So 105 upon 7, that is equal to 15, right? Trimmed mean example. What do we say for that? Trimmed mean, what we can say is, it is similar to adjusted mean, is a method of averaging that removes a small designated percentage of the largest and smallest values before calculating the mean. As I told you that the data is available in sorted manner, and let us say we remove the first value and the last value, right? So we have chopped say particular percentage of the data, that is from the largest side as well as from the smallest side, right? And then after calculate the mean, right? So that is called the trimmed mean. After removing the specified outlier observations, the trimmed mean is found using a standard arithmetic averaging formula. So for that, the example is there. Say find the trimmed 20% mean of the following test scores. So scores are say this for 1, 2, 3, 4, 5. 5 values are given to us. Now, how to find that? Trim the top and bottom 20 percentage from the data. 20 percentage of 5 data is 1. So remove top and bottom 1 values from the data. So what we can say? 60 will be removed and 99 will be removed. So we'll be having the data, that is 81, 83 and 91. What is the next step? That is the find the mean of the remaining values. So trimmed mean is equal to 81 plus 83 plus 91 divided by 3. Now do not consider the total 5 numbers were there, right? Whatever remaining numbers are there, for that we need to find the mean. Okay, so 85 is the trimmed mean. Median, what is that? The median of a set of data values is the middle value of the data set when it has been arranged in ascending order, that is from smallest value to highest value. If say marks of the students are given here, and if we want to find the median of it, see, this is not the sorted data, isn't it? 47, 35, 37, 32. You can understand that it is not sorted data, right? So we have to first sort the data in ascending order, right? So what do we say? This is sorted data, right? Sorted data in ascending order. So what is after that? We know that 1, 2, 3, 4, 5, 6, 7, 8, 9. So total number of values given are 9. That means odd number. So for that, we'll be taking the middle value. So for middle value, what do we say? For that, we can say middle value is this 36, right? Middle value is 36. So that is the median of the data. And if it is, say, 10 data values, then what could we have done? We could have taken, say, one more value is there here. Then we have to take the average of the middle values. That means if say here again 35 is there, so you can say instead of 9 we'll be having 10 values. So 35 plus 36 divide by 2, right? That will be the median of data if one more 35 is there. Fine. Next is mode example. So what do we say? Arrange the data values in order from lowest to highest value. That is, sort according to ascending order. Fine. Now, what do we do is, the which data is, you can say the mode, that is we can say the number which is available more frequently, right? Here you can say the fifth data value, that is 36, is the middle value in the arrangement. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this 36 is the middle value, but that is being said as median, right? So what is the mode? Mode, that means what we can say is the number which is being found more frequently, or not more, most frequently in the data. So here you can say 32 is available once, 34 available only once, 35 available twice, and all other values are available only once. So 35 is the mode of this particular data, right? You can say if say 35 is available twice, if 36 also is available twice, then we can say that data is bimodal. It is having the two modes, right? It can be having the more modes also. Fine. So here, let's see that example. Say categorical or discrete variables are there. Categorical where the categories are there, right? Okay, so here say this 750785541, right? Sorry, yeah, 5. So now in that, what we can say is the mode. Mode means the number which is occurring most frequently. frequently, right? So here you can say that 5 is available 1, 2, 3, and 4 times. Another data is not available that many times, right? So mode is equal to 5. Okay. Now if the data is 14, 14, 15, 16, 14, 16, 16, 18, 14, 16, 16, 14. So now for this data you can say 14 and 16 both are available most often, that is 5 times. And so this data set is by model, right? Categorical or discrete variables only we are considering. What is the data given here? That is 0, 0, 1, 0, 0, 2, 3, 1, 0, 1, 2, 3, 1, 0. Let us put the data in the order, right? That is the sorted order. So what is the most frequently observed data value is 0, right? So we can say mode is 0. Fine. We can say mode is 0. Fine.